All right, welcome to the quick little 3D printing workshop. So, first off, do you guys know much about 3D printing, what it is, how it works, or anything?
I'm no expert, but I've 3D printed a couple of things at the makerspace.
Okay.
Yeah, my high school used to have like 3D printers and with like resin and everything, and those were pretty cool. So,
Okay, cool. Yeah, so it's a pretty crazy, wild, there's so much to it, but I'm going to show you kind of what I know and what I've used. So, this picture right here is a picture of one of my 3D printers. And yeah, so it comes somewhat pre-built, and I built it up and some of those blue things, basically all those blue things, are stuff I printed and added to it and modified. And yeah, we'll kind of get into it. So this is back at home. This is like my full setup I've been working on. So I have two 3D printers. The blue one is from Creality, and it's the Ender 3 version 2. So yeah, this is my setup. The blue one again is the Ender 3 version 2. It's just one type, and then so the Enders is like a whole series from Creality. So there's the Ender 3 version 2, and then the red one there is the Ender 3 Pro. And they're basically very similar machines. They're very small. They're about I guess in total size they're about less than 500 millimeters cubed, and both of these have about a bed size or a build volume, basically the area to build, of about 200. I think it's 220 by 220 by 250. 250 is the height, and so yeah, they've got basically four motors. I'll get into some of that, but then they got um, both have a little display thing, and you can put in a SD card to be able to print and stuff like that. But this is just my little setup where I have everything, and I built a little shelf. Those black things are things I actually modeled myself and printed. So that was pretty cool. Built a little shelf with that.
I'm just
Um,
curious, what software do you use to model this stuff?
so for that, I used Fusion 360, but I mean, I'll kind of get into that and maybe show a little bit. I'll pull up that model and kind of show you guys more. But yeah, this is my setup at home. It's pretty sweet. I've been working on it basically over the past summer. I started working on it, and yeah, got it to there. It's pretty cool. So, what is a 3D printer? So, if you don't know, 3D printer is a basically machine. I guess I refer to it, and people refer to it as machines of the additive manufacturing process. And basically, what the additive manufacturing is just basically material is added and built upon itself to create objects, 3D objects, 2D objects. There's many things you can do with it, and there's also an insanely large amount of techniques and things and just huge depths into the manufacturing process. So some of these techniques include the FFF or FDM, which stands for fused filament fabrication or fused deposition modeling. And both of those are extrusion type base, where basically the material is extruded out of a nozzle, and it's like extruded and like melted onto itself. That kind of acts like as like a glue, so they kind of like stick to each other. Then there's SLA, which Sarah, I assume you maybe have used before with the resin. That's called stereolithography. Let me say that right. It's a large name, so stereolithography. That's it. Stereolithography, which is basically a printer that uses resin and a very powerful light, and the resin sits in basically a vat, or it's also known as vat polymerization. So the resin sits in a vat and is shot at with a light, and then that light cures and hardens the resin. Um, so forming, yeah, slowly at a time, it forms and forms polymerization chains, and that basically builds up a model, a full object. Then there's also another, and these four are like the pretty big ones that are used. So the next one being SLS, which stands for selective laser sintering, which is basically a powder-based one where it uses powder. The ones I know of, it uses nylon powder, and the way it works is there's basically a bed or a coat of powder, and then they're using a high-powered laser. The laser gets directed and selectively lasers, and it's called sintering, where it basically heats up and fuses the powder together, forming, again, more polymer chains. And so layer by layer, the powder is sintered and fused, and that creates an object. And then another one I looked at was called AJP, which was aerosol jet printing, which is basically a droplet type based printing, and it uses kind of not necessarily air, but just like it's like more of a gassy one where it's like it's extruded out, but in droplets, so it's like sprayed out. I guess I don't know how else to say that at the moment, but basically with that, there's very fine droplets that kind of get I'm blanking on the word, but they just get squeezed out through a nozzle, and then they kind of get sprayed onto maybe an already made object, or it can be used to even build objects. Spraying the droplets upon itself. And so those are just some main ones, but there's a bunch of techniques, including SLM, DMLS, EBM, BJP, PJP, PED, PEM, DLP, LOM, WAAM, EBF3, LDM, and basically these are just a whole bunch of different ways, and let me find what all those mean. But some of them are just like selective laser melting as opposed to selective laser sintering. Then there's direct metal laser sintering, and then there's electron beam melting, and precise extrusion deposition, binder jet printing, polyjet printing, precise extrusion manufacturing, digital light processing, and then laminated object manufacturing, wire and arc additive manufacturing, that's what it stands for, wire and arc additive manufacturing, electron beam, freeform fabrication, whole bunch. There's just a whole bunch of crazy stuff where you can just use materials and fuse them in different ways to create objects. And of course, there is the spectrum from hobbyist to industry level machines. And of course, the one I have is more of a hobby one, the Creality and the 3v2. And this machine is only about $270, so it's pretty cheap.
That's all the 3D printers I've heard of are like way more expensive than that.
Right. So there's
like $1,000.
Yeah, so there's a huge range. So this is the one I have. This is one of the ones I have. The other one was about 230 or whatever at the time. But these guys are the FDM/FFF type printers, so they use filament as the material and basically build up the models and objects with the filament. And yeah, on the other hand, there's the industry level. I don't know too much about the industry because I don't work in the industry, but yes, there are plenty of machines that cost thousands and thousands of dollars, $10,000 to $100,000, maybe, giant ones that cost $200,000, $300,000, $400,000. But essentially, they mostly all work in the same way, at least within, the technique. Like some, even in the industry, some are extrusion based, extruding filament, or there's huge SLA printers that have a large vat for resin and do things the differences being they do things faster or bigger or just more accurate a bit than some of these hobby ones. Same thing with SLS. I think when I was looking this up, the cheapest SLS one is a kit that you have to buy, and it was about $6,000 to buy the kit, which you have to build completely by yourself. And so yeah, it can get pretty expensive. It can get pretty big, and there's a reason there's industry level or industry grade machines versus the hobbyist one, because as you can see, this is just a small aluminum frame that basically just works with four motors. And to get into that more, this is the filament that is used with the FFF or FDM type printers, where it's like a wire or spaghetti type material that's wound on a spool, and that kind of gets inserted through the little tubing into the place where it will get melted and push through into the nozzle. And with filament, there's about infinite colors you could find, every color of the rainbow, whatever. And then there's even mixes like carbon fiber infused, so some that have more strength, even glow in the dark. So it's like you can heat it up in the or whatever light sun, and then like it glows in the dark. Pretty cool. And then there's even mixes of colors. I have like a rainbow filament that changes from one color, red, to like green, to like yellowish, back to red, purple slash to red. And then even there's like a bicolor one where it's like it's split kind of down the middle, and half of it is like let's say red, and the other half is blue. And there's kind of two colors, and yeah, and this is just kind of the material for FFF FDM printers. And so this is kind of how they work. So there's basically 4 motors. One controls the x-axis, one controls the y-axis, which is the bed, and then one controls the z-axis, and then one also controls the extruder, which will extrude or pull back the filament based on where it needs to print. And this one specifically uses a belt for the x and y axes. So as you can kind of see here, this is the X motor, and there's like a belt thing. And well, I guess I'll get into that. But yeah, so there's a 4 motor. So this one, the blue one, is the extrusion motor. This green one is the X motor. The Y one back there, right here, is the Y axis. Sorry, purple one is the Y axis, and then this red one is the Z axis. And so these are just kind of the 4 motors: Z axis, Y axis, extruder, and the X axis. And so for the extruder, you can tell that they're sticking out. There's a bit of a teeth type thing, and those teeth kind of grab onto the filament, and there's a bearing here. So the teeth and bearing kind of grip and like are able to move the filament back and forth to either extrude or pull back on it. And again, that's just the x-axis one that uses the belt. Y-axis also uses the belt, as you can kind of see. And for the Z one, there's this screw where it kind of screws into here, and when the motor turns, it like screws it up or down, basically. And that's how you kind of go up in the up and down direction. And for most of this machine, they roll on the extrusion rail. So hopefully you can kind of see some of these. I probably should have got rid of that. But hopefully you can see kind of some of these wheels, and they fit kind of into these slots. And that's kind of how they move. So yeah, moving on to some more details. I like to do a lot of mods. It's pretty fun. And some of the mods that I've done on my machine here are I've added some sweet color to it. I printed out a tool holder, kind of slides right into the top slot there, and just holds all the tools needed for the printer. And then it's got some feet on here that kind of dampen the noise and vibrations and stuff like that. And then I have this little guy, which is like a bit of a guide for the filament. You can just stick it in, and it keeps it nice there. And then I have another one here right before it gets into the teeth bearing right there. That just helps a smooth flow for the filament to go through, so it doesn't pull or like drag in or anything like that. And then one of the more complicated mods I've done is within the hot end. This is where it heats up, and there's the cooling part too. I put a different type of tubing. As you can see here, there's like this white tubing, and then there's this blue tubing. This blue tubing has like a higher heat resistant, and so I put that where it gets hot, and that kind of helps with some things, and where it doesn't melt or burn this other white tubing. And then another thing I've done is I've added a Raspberry Pi to it. That has an OS called Octoprint running on it. So just like Windows or Mac OS or Linux, on the Raspberry Pi, there's one called Octoprint that is specifically for 3D printing. And even with that, I've added a camera to it. So the camera, I think it's like a 1080p one, so it's a pretty good camera, and I can use it to look upon the printer while it's printing. Oh, sorry, I skipped one. I thought that was the hot end. And then I just have this other mod here that makes sure that the tube is nice and snug and fit and stays connected to this portion, so it doesn't uh, get pulled out or anything like that. So far, any kind of questions?
Sorry, I came in late.
You're good.
Is this your 3D printer that you made?
This is one of my 3D printers. Here, I'll go back real quick for you, Jeff. So this is my setup at home. I've got 2 of them. But yeah. So this is the one I've got, and there's some of the things I've did to it. Any comments, questions so far?
So you were talking earlier about mixing the colors and having like multiple colors in one print.
Right.
So my question is, can you have like multiple feeds at once, or do you like switch out the color and then it's switch out the spool?
Right, so I guess it
When you want a color
depends.
changed.
So I have this one spool where it's made to be like a gradient. So there's a spool that has like multiple colors in it. There's also another spool that has like it's split down the middle, so it prints 2 colors at once. Where it's like if you look at it on the front, it may be blue, the back is like red. And then there are more advanced machines that have multiple heads, or maybe it can change the tool that's on the head. And it gets complicated where you can have multiple single colors and it will change and like specifically print multiple colors like in a print. But otherwise, what you can do is, since it prints, from bottom up, you can change the color at a certain height and have multicolored prints that way, changing out the spool yourself like that. So there's quite a few ways to get multicolor prints. That do it?
Yeah, no, that
Okay.
did it.
All right. Anything else? You good?
So does the Raspberry Pi control, like, is Raspberry Pi the brain?
The Raspberry Pi is not the brain. It's more like an addition to the brain. The 3D printer has its own software and everything. That's why there's an LED screen. The Raspberry Pi was an addition. It was a mod that has its own OS running. I don't know if you heard that part. It has its own OS called Octoprint. And I'll show that in some details, but it's basically an addition, and I can control everything through there. But there is its own motherboard and hardware that controls the motors and temperatures and screen, etc., everything like that.
So what happens if it is too hot and you try to print? Is that like a common issue?
No, because there's software that controls the heat and stuff to make sure it's a specific temperature. I'll get into all those details, so it'll be more clear in the future. I also forgot to mention my favorite one being this BLTouch, which is this little white thing here. Basically, it's a probe. So since it's just a machine that has motors, you kind of have to tell it. You kind of have to. Oh god, what's the word? You kind of have to calibrate it to make sure that when it prints, it doesn't print in midair. Like it prints close to the bed so that it sticks, and so that the object like is actually building upon the build area. So usually you have to manually level it. It's called leveling. So usually you have to manually calibrate it or level to make sure there's just enough space between the nozzle where the material comes out and the bed for it to stick, and thus you can make the object. Otherwise, with this BLTouch, what it does is it goes around, and mine is a 5x5 grid, and it takes probe measurements of the bed so that it gets very small, pretty accurate measurements of what the bed looks like. And again, I'll show that into more detail, but it's one of my favorites. I barely, with this one machine, since I have it set up, I barely have to do anything. I can kind of just print with it. So yeah, continuing with that. How it really works is, first off, is you got to make a model. So you can use something like CAD, a CAD thing like Fusion 360, I know there are a bunch of other CAD things, or there's stuff for modeling, like art modeling, like what's it called? I'm forgetting the name, but
Blender.
yeah, like Blender, or the other one, Maya. Is it Maya 3D or something? It's basically stuff like that. You can use anything, make a model, and with the model made, then you can save it into some file formats. One being STL, which I think is the lithographic file, OBJ, like an object file, or this new file, which is specific to 3D printing, called the 3D model file. And then with that file, you can upload it into a program called a slicer, like Cura. And what the slicer does is you can set up the model for printing, and then it slices the model into layers. And slicing this produces G-code. And G-code are the very basic, like super basic single instructions that are read by the machine, that moves the motors, heats up the hot end, heats up the bed, and works with like the BLTouch, and basically just communicates everything from a file to the machine. And with Octoprint, and it's an accessory OS ran on the Pi, which I can control the machine wirelessly. I have mine hooked up through Ethernet, so I guess it's a bit more wired. But I can, it's hooked up onto my network and the BLTouch. And then the last note, I'll show you some printing before I kind of get into my process and how to do it. So there are the different types of machines. Just focusing on FDM, there's like a Creality series, which is a pretty popular one, which are basically pre-built machines. So most of it's pre-built, and you only have to, screw in a couple things, make sure it's all kind of you just kind of have to do some of it yourself, as opposed to something like the Voron, which is a fully open source and custom build where you have to source every single part. There are kind of some kits, but you have to buy basically everything and build it all from scratch, wire it, hook it all up from scratch, and do it yourself. So here's a couple videos to show you some printing in action. Let me scroll to the part because the YouTube start at time never works. I forgot where it was. Alright, and so here's just a little thing. So here's how it works. It's just homing right now.
And then hopefully begin our first print.
Let me mute that. And so that's just the Z axis moving it up and down right now. And without the BLTouch, there's a little thing right here. It's just a little switch that basically tells it it's about to hit the bed. And there it goes. It's moving pretty slowly, moving each axis independently. So it can make straight lines, or to do like diagonals and circles, it moves multiple motors at once. To get all those kinds of things. I guess let me skip ahead to the print now. I guess I'm gonna go a little more. So here's just a little. So you saw how slow I was printing. So there's just a little thing. Oh man, that belt is really loose. But yeah, it just moves back and forth, and then at the same time you can see this is the extruder. It's like moving back and forth. It's pushing filament through, or pulling it back when it doesn't need to. And yeah, it kind of just pushes material. And the best way to think about this, a great example I've heard is like using a hot glue gun. So if you yourself were trying to make something, it's like using a hot glue gun, where you take the hot glue gun and you need a hot glue stick. You heat up the hot glue gun, you put the stick in the hot glue gun, and the trigger is kind of like the motor for extrusion. And in order to make something, you have to start on a flat surface and then build the first layer of it, right? Put down the first layer. Let's say if you're just making cube, you put down the four sides, and then you can fill in the center with like the hot glue gun. And you have to make sure your arm is flat, so you're squeezing the hot glue onto the bed to make sure it sticks. And then you kind of build up from there. You move your hand up a bit, and then you start the next layer squeezing more hot glue. And it kind of works like that. And here's a sample print from that. Then you can get pretty crazy. Close. What the heck? Okay. Here is the Voron build, which is a basically custom, a open source custom one where you have to order all these parts. So you literally have to order every screw, every nut, every fan, every belt, every little thing, and build it up all yourself. And this is vastly different compared to the other one. The other one moved quite slow and was more basic. This one, so the Creality machines are about $200-300. This one, I think, if you source the parts yourself, is about 1,000, maybe 1,200. Could be a little more, but you'll see just how different it is compared to the other one. So this is in real time, printing a little test boat, and yeah, just look at it go. You can.
That's not sped up. Wow.
Nope, not sped up. So
That
this
looks
is
very sped up.
yeah, it's real time. So you can just see the object just appearing in front of your eyes with this insane speed. And yeah, we'll just watch this for a bit. Maybe I'll skip ahead, but you can just see how fast it can get with this specific build. It's called the Voron. And just kind of appearing in out of thin air. But again, this one works the same. There's the tubing where the filament gets pushed through the tubing to the hot end where it gets extruded out through the nozzle. And yeah, we'll just kind of skip ahead closer to where it's finished. Let's go here. And, it's pretty insane. I'm thinking about building one of these myself in the near future. Gotta save up a bit of money and build out a chunk of time to make sure I can build it and make sure it works by the time I'm done. But yeah, this is just so cool just watching it just go brrr. I mean, here, I'll put the sound on so you can go back a bit. But it's schmoving. And yeah, there's a little boat that I printed in 3 minutes, which is insane. Usually these take me about like maybe 2 hours, an hour and a half or something with my printer. So, but those are just some of the differences with that. How do I? Why can't I? Okay. So that's like a cheap pre-built compared to a more sourced assembly one. No. Go to the next slide. Okay. And so just going through the Octoprint again is run on the Raspberry Pi, and I have it hooked up in this little wire that connects to the printer, and that kind of connects everything, and so that they can kind of communicate. And then I've got it hooked up to Ethernet, and then I've got a Raspberry Pi camera so that I can look through it. And to kind of show that, this is what it looks like. So hopefully this is all good. Cool. So this is kind of what the homepage looks like. So this is basically the Raspberry Pi running all this, and I can go ahead and kind of control everything. So right now it's just these are the temperatures for the tool in the bed. I'm gonna go ahead and start heating that up. So by the time I'm done, it should be nice and heated. So the material usually gets heated up to about 200, around 200 degrees Celsius, and then the bed is about 60 degrees Celsius. And we'll let that heat up. And also you can see the live camera feed. So that's what it looks like. So, I mean, hello, it's me. And got that camera attachment to look on the printer so I don't have to look at it. Right now it's close by, but usually back home I have it in my garage, which is not close. So I can look at it far away. Make sure it's printing right, etc. And I can control the axes, so I can kind of home the printer right now. And it's just moving. Can let that home. And there's some other cool things you can do. So you can even view the G-code. So when it's printing something, you can see what the G-code is. And then here's like the terminal showing all the stuff. And then you can do a time lapse with that too. But here are all my files, and basically all I got to do is just upload a file. So real quick, I guess going to that, let me open up Fusion 360. I'll just quickly show you one of the things I've done. So this is a CAD program I've used. I have to get used to the controls. Everything's different. So this is something I've made. How do I do it? Shift. Okay. So this is something I built up myself through here, and just kind of some basic shapes, and then I added some screw holes. And with this, take any model, and alongside that you can also go to websites. There's a bunch of websites. So there's this one called Thingiverse where people upload their models for free, and there's just crazy amount of stuff on here. I've printed a lot from there. But basically you kind of just can export as a bunch of these files. So the one I mostly use is STL, but then there's OBJ, and there's like the 3DM, which is kind of, or 3MF, which is like a newer file. But yeah, you basically kind of just can just save the model. And then with that, I guess real quick too, since I'm going to try to show you a real print, I'm going to print something out. I'm trying to look for a Christmas tree ornament. That's not Christmas. I spelled it right. So I mean, you can literally search for anything. These are some things I printed out. It's like a little build thing. Like you print it and you just take out the pieces and can build it.
Have you put anything on Thingiverse?
I have not yet. I have a couple things I probably could have, but I just kind of didn't. I'm thinking about maybe doing that one. But yeah, there's some cool stuff. I mean, this is just Christmas tree toppers, so I mean, you can see how many things people have done. Maybe I'll do that one. That one looks nice. Which one? That one or this one? I think I like the other one better. And so I'm just going to go ahead, I'm just going to go download the file. It's the STL file. Got that guy downloaded. And then now, this is called Cura. Just go back to my... And then, so this is basically what the slicer looks like. So, just a quick view of it before I do it. But yeah, you can put the model on, and then when you slice it, this is kind of what it looks like. So here is Cura. Let me go back. Is it showing? Hopefully it's showing Cura. Okay. So yeah, I'm just gonna go ahead and insert that file. So got the star. And so here's the model. It just throws it on there. I gotta make sure it's nice and flat. That's what that blue tells me, that it's nice and flat with the bed. And here's just the model. So I can go ahead and move it on the bed, or I can resize it, make it, you know, big or large. You know, you can rotate it, etc. And then there's a couple things you can do, but I'm gonna just leave it like that. And then there's a whole bunch of settings you can do, from the height of the layers, which is basically kind of like similar to the resolution. The smaller, like the less you see the lines, basically, you know, how many walls, which is more like for strength, you know, how many walls it'll put around the perimeter. And then there's stuff like infill, how much it will put on the inside, basically between all the walls, which also gives it more structural support. And then, you know, changing the temperature for materials and stuff like that. And then the speed of the machine itself, the motors, etc. And then just some other stuff, some cooling, and then there's something called the support. So if, let's say, I was printing like this, printing it up, you see how there's kind of some of it is just kind of in midair. You need some supports, and these supports will basically support that area so it's not printing in midair. So as you can see, it'll added that to it so that when it prints, has something to print on, and then it kind of prints like that. But I'm not going to do that. I'm going to just leave it flat like that, and reslice that. And so this slices it basically into layers. I'm also going to change something real quick too. So those white things are basically where every layer starts, and I can change that. So if I change that to back, it should line up nice there, so you don't see it as much. I think I'll leave it like that. Yeah, so this is what it does. Slices it into very, very small layers. So this is layer 1, where the red is the outer wall, the green is the inner wall, and then the yellow is for the bottom layer. So you fill out the bottom layer, and then it just kind of goes up layer by layer. And then that orange stuff is the infill. So between the walls, it starts the infill when it's not, full like that. And then you can kind of see that in between here, there's some more infill and stuff. But yeah, and then so it just kind of goes layer by layer, and it's kind of how it works. And you can kind of see it just is building layer upon itself until it's fully complete. And then I just go ahead and save this, and this saves the G-code. Alright, so this is kind of what the G-code looks like. So these are literally the basic instructions for the machine. So there's a couple here. So like M104, S200, it's setting the temperature to 200, and that's like the temperature it really tries to stay around. It heats up, cools down, etc. So basically turns on the heater, turns off the heater, lets it cool, etc. And then this is the whole file for that whole star. So for this little star thing, it's this whole thing. Every little code for every little movement, X movements, Y movements, extrusion, and it builds up the whole shape. So in this one, there's only, I guess, besides all that, about 78,000 lines of code. So for that one object, 78,000 lines of G code to move every little motor movement, X, Y movement, extrude a little bit, and that's kind of how that works. So now back to actually doing it. I guess I didn't do that yet. But back to the Octoprint. It's now hot and ready. It's homed, and now I'm just gonna go ahead and upload this file. And I just go ahead and upload that G code. And now that G code is ready to print, and all I have to do is load and print it. And so what it's going to do first, since I'm printing this on this machine, it's going to do the BLTouch. And so what the BLTouch does is this. There's this add-on for the bed visualizer, and this is basically how flat the bed is. And so what it does is it adds these little variations to the code so that it prints perfectly flat. So this little corner is up a little higher, so when it's printing up there, it moves up slightly just to make sure that it prints constantly, constant distance between there. And green is very good, so it's pretty flat. And so here it goes, and it's just going to start probing around. And it takes those measurements basically and applies it to the model. So it just goes across the bed. And this takes about 5 minutes before, or like 4 or 5 minutes before it'll start to print. But I do this every time because I want to make sure the print is nice. So sorry, just to re-explain for the recording. So the G code again is just those. It tells the motor in the X direction to move that much, the motor for the Y direction to move that much, and then the extrusion motor to move that much. And that's basically all it is. It's really just G code. But again, there's the flavors of it, I guess technically, which is like flavored marlin. One sec, I'm just gonna change the filament real quick. I'll be back. So now it's started to print, and we'll see it get. All right. So did you have a question or comment? Nope.
It's pretty cool. I mean, I've used Fusion 360 before, but it's
Mhm.
just nice to see like the beginning to end process. Like,
Yeah.
yeah.
And Fusion 360 can get real complicated. I just use some basic things where I just built like a block and then, extruded and cut some things and stuff. But you can do some pretty complex things to create some complex things for CAD or even for modeling in general. Um,
Yeah, definitely. I've used YouTube tutorials to do them, but
yeah, same.
yeah.
But yeah, there it goes, and now it's just printing. And so I forgot how long it said. In about 3 hours time, I'll have this little star tree topper put on top of the Christmas tree.
And is really the only limit just the size of the printer?
Kind of, because you can always cut the model into pieces and have like a little connecting piece, so you can just print it into pieces and then connect it. There was a video a while back of a guy who like also there's some other things for modeling where he took a 3D capture device and took pictures of himself, which made a model of himself using like capturing imaging or whatever, and then he printed a full size thing of himself, and how you put it in pieces of like feet, legs, upper legs, exact torso, all cut up, put it together, and then had someone paint it. And so he printed a copy of himself in plastic. So you could kind of get around that, but yeah, for the most part, it's pretty limitless. You just have to make sure it's calibrated right, make sure it's all greased up, everything's tightened, kind of all that. Make sure the software is running right. Um, but yeah, with that, it can kind of pretty much do anything. So yeah, pretty cool. Um, Love doing it, and yeah, I mean you can see how much I've done with just to go back to my setup. So with this one, I printed a new like a hot end shroud that holds like fans. I even bought a Noctua fan for this one just to see how quiet it would get. Noctua does make tiny fans like that, which is pretty cool. But yeah, so I mean, maybe you guys have heard of the company Prusa, but what they do is they actually print a lot of the pieces for their printers. They print them themselves, and that's what you get sent to build for some of the things like the display and some other things. Because the pieces can be quite strong. They can be, depending on the material and stuff. I guess I forgot to mention this is a PLA material. It's called polylactic acid, which is actually made from corn syrup. Um, so it has pretty strong durability. It's quite strong, but it's not so heat resistant. So if you leave it out in your car in the summer, the part will melt and deform. So there's a downside with that. But there's a ton of materials. I maybe could have added that part. But similar to like the different resins and powders, there's kind of a whole bunch of things to use. There's a lot more I think with filaments. But also the good thing with PLA is if you do it correctly, it's biodegradable. And if it's straight PLA, it's biodegradable. If you start adding stuff to it like carbon fiber or some other, enhancement mixes or whatever, that changes it. But yeah, it's pretty cool. So all this stuff is made from PLA, and it's quite strong, honestly. And so again, these brackets, I think you missed that part, Jeff. But yeah, again, I made that and printed these brackets for the shelf here. And so it's
that's cool.
yeah, so it's holding up, I don't know, 5-10 pound piece of wood, and then each of these spools is about 2.2 pounds, so 1 kilogram. And yeah, so I mean, it can replace some of those things, like some metal brackets, wooden things, all this stuff, it can be replacements for and hold up quite well. So, anything else? Any other questions, comments, things you got? I'll go back to it.
Have you ever heard of oh, this is kind of off topic and might be a stupid question, but have you heard of like 3D printing food?
Yeah, and it's not. I mean, I guess it depends on food, but I know Linus was messing with one, and I saw someone else where they were trying to melt chocolate and build things out of chocolate, where it would melt the chocolate and then extrude the melted chocolate and then cool the chocolate. Basically, this very same process, just with chocolate, and it kind of worked. Another one I saw, another filament I saw was coffee infused, where he ground beans and mixed it with the plastic, and when it was melting, it smelled like coffee, and it had a really cool texture. Not quite edible. I'm not so sure on how much edible PLA is, because it is made from just corn syrup, but again, there are the additives and stuff. Where I don't think you would die. I don't think you'd like get poisoned, but it's plastic and you probably wouldn't digest it well or something. So don't eat it. But yeah, maybe in the future.
Didn't they make like edible water bottles or something? That was like, I don't think that was 3D printed though.
Oh, I have no idea, but I'm sure they could. I mean, I don't know how the chemistry changes stuff. Like, because again, this is made from corn syrup, so corn syrup you can eat, obviously, but I don't know what the chemical process is, if it changes it a bit so that like your body can't digest it or something, but I mean, I think there was that gum that had those wrappers that were like edible wrappers. It's a bit different than plastic, I guess, but yeah, maybe soon can print food and stuff. I don't know if it'll be like Spy Kids, where you just pop in the little thing and it'll print a burger or something, but yeah, maybe. Let's say the automotive industry, they use that to prototype with cars. Like, you can 3D print a whole life-size car if you wanted to. I mean, it would take a while, but that's definitely what it's capable of. Or for smaller things, like things that are already made out of plastic, like caps, or like things, or like the interior, or like whatever. And yeah, and I mean, I've seen even a ton of things just with cars. Like, someone made a cup holder that fit into the cup of the car to then fit the smaller bottle or whatever, more snug. People have made dipping sauce things where you can put it on like the little fan thing, and it holds like dipping sauce, so you can dunk your nugs while you're driving. Just, I don't know, some fun things. Just another one that I thought of was people were using it for animation. So, usually how clay animators, or like those frame-by-frame animations, they would use clay or whatever to manipulate it. People printed models with it, with small, like, movements of motion or whatever, so that they can use those models to both use for the actual animation and for prototyping. So,
Pretty cool.
yeah.
Imagining why ship goods when you can just manufacture them on site.
Yeah, and that's definitely another thing, is like, like, if you order something online, like maybe nowadays it's a little worse, but let's say Amazon pays their employees well, they don't work 40-hour days, etc., where things slow down a bit. Well, this will come in handy, because then you don't need any of that. If you just have this machine at home, you can just buy the file or whatever it is, buy the material and have the material already, and then you just hook it up, set it up, print it, and within, you know, mostly within a couple days, you can have a lot of things. The biggest thing I've printed took, I think, less than 24 hours. Maybe it was like, I don't know, 28 hours or whatever, but that's not a whole lot of time to wait. I mean, as opposed to waiting a week or whatever for what it, you know, maybe a couple days for whatever you order online. And it cuts all that down, right? All the insane amount of handling and overworking or whatever it is that happens in the industry. You can just buy the thing, hook it up, plug it in, print it, and wait, and you've got it right there. So yeah, I'll just wrap it up here, and thanks for coming, and thanks for watching if any of you watched the recording. So thank you.